Sam, are you there?
What? Hello, Smith.
Hello, hello, hello.
Hello. Do you hear me? Okay, anyway.
Can anybody out there hear me? Can you hear Mr. Pham?
Yeah, I hear you. You hear me? Okay. Anyway, last time we already start with the flip-flop. That's a very important for technician. Okay. And we already talking about the D flip-flop and the JK flip-flop.
Mr. Pham, are you recording?
Yeah, I already recorded.
Okay.
This is a D flip-flop. And that one will be JK. You get only two flip-flop. Okay. And this what for the D flip-flop. Basically, they will be input D, output Q. Flip-flop all the time. You get two output, Q and not Q. If Q is equal 1, not Q 0. If Q equal 0, not Q equal 1. Same thing for the D and the JK flip-flop. Okay, now for the D flip-flop, they're using the clock going from 0 to 1. Okay, that means if you get the input 1, output cannot equal to 1 until you get the clock going from 0 to 1. Then Q equal 1 and not Q equal 0. If the clock equal 1, output cannot be changed. Or clock equal 0, they not change. They have to get a transition 0 to 1. In the system, we're using P, C, L, K. P clock for the clock going 0 to 1. Okay? So if you want the clock 0 to 1 in the program, you call the function P clock. Okay? That's a very simple about the flip-flop. Another flip-flop JK. JK will be opposite for the clock with the D. JK, the clock will be going 1 to 0. Okay? And you get the truth table here. Okay? If J equals 0, K equals 0, you get the clock going high to low. Output will be no change. J0, K1, clock going high to low, Q equal 0, and not Q equal 1. If J equal 1, K0, you get the clock Q equal to 1. If J equal 1, K equal 1, and the clock going high to low, output toggle. What that mean toggle? What is a toggle?
It was 1, now it's 0, or it was 0, now it's 1.
Right. That's what we're telling you. Toggle. If it was 0, now 1. Okay. Or okay. If was 1, now 0. Okay. And in the program, you want high to low clock, you're using and clock. That will be given to you 1, 0. Look here. Okay, so basically, what the clock inside the computer, they only using to store the value Q equal 1 or 0. So you get to get the computer 32-bit. That means you get 32 flip-flops. So they can store the value into the location of the 32 flip-flop. Or 64, you get 64 flip-flop. Okay? And now this will be 74. D flip-flop. Okay? Normally, flip-flop and flip-flop. Now, and get or get and get everything. 14 will be VCC and 7 will be route. Okay? And if you're looking into the diagram, okay, this is the IC here. 14 inside, they get 2 flip-flop, 1, 2. Okay? If you're looking on the first one, what pin number 1? Pin number 1 go to clear. Pin number 2 go to D input. Pin number 3 go to preset. Okay. Pin number 4. 4 go to preset. 3 go to
Clock.
clock. Okay. Pin number 4. Okay. Pin number 5 go to kill. Pin number 6 go to not kill. That means they're telling you, okay, you get two flip-flop and what pin doing what, okay? And now they given you another one, JK 7476, okay? On this IC you get 16 pin, okay? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. If you're looking into, okay, the diagram for the JK, pin 5 for 5 volt, special, okay? Here, 5 volt. And the pin number round will be pin 13. That's a different with normal IC, okay? And also they're telling you what pin 1, pin 2, 3, 4, okay, whatever. 14, 15, 16. What is it? Is it a J or K or clock? Okay. You're looking into the diagram. You can see you get two JK. And also they're telling you what pin doing what. Okay. But the important thing is 5 volt power supply will be go to pin 5 and ground will be go to pin 13. Okay, what they look like here. Basically, when you connect the clock, okay, you go to the inverter, okay, and the clock high to low, then go inverter, they will be opposite, okay, low to high, then now high to low, okay, go to the inverter. So one go directly, okay, to the inverter here, okay. If they low, so they high, and the output will be going low, going high, okay. The other one will be same thing, okay, with the input clock. What they want to do here, they telling you they want to get the transition high to low to high, okay. That is a transition. Or another inverter here, you can get 0, go 1, and go 0. So even you apply one clock, if you add in the inverter and the NAND gate, you're able to get, okay, high to low transition or low to high transition, okay. That's what they try to telling you, how to create the clock transition. Okay. However, you're working on this lab, you don't need that. The thing is you already get the P clock or N clock. They will do it for you. Okay, now some very special, and you have to remember. This is the D flip-flop. When you connect not Q back into D. So if you get the clock, output Q will be toggle. That means if it's 1, now they go 0. If it was 0, they go to 1. Okay? So if you get the clock 0 to 1, output toggle. Okay? What that mean? If you connect not Q back to input D and you apply the clock 0 to 1, output was 0, now go 1, or it was 1, now go 0. That will be the same thing for JK. If you connect a J and K, to logic 1, high to J and K, and you get the clock going high to low. Then output will be toggle. Okay? So this is the clock here, okay? Let's see. Okay. So if Q0, when the clock going, they toggle, they go 1, and they toggle, they go 0. Okay? That's what you need to know. And now, they just try to see you understand the timing or not. Okay? First thing, you see not Q here. Connect D. QA will be toggle. And same thing, not Q, B, connect D, QB will be toggle. When they get a clock, okay? So they're telling you here, when the clock going low to high, QA would 0 now go to 1. Okay? And QA now will be the clock for the second one. Okay? So for the second one, the clock will be here. Okay? When you get a 0 to 1. Okay? And let's see, QA 0 to 1 here. So QB toggle. Okay? So if you have to draw the waveform. Then anytime QA goes 0 to 1, and this guy will be toggle. Okay? And now they're using connect the JK. So basically, you have to go through that, try to understand. Okay? However, in here, we already given you output QA and output QB. Okay? So JK connect to 1. That's only telling you Q output of the flip-flop A will be toggle. And the output of A be a clock for the next JK. So QA you going high to low. Okay? Then QB toggle. Okay? You see that? High to low. It would QB would 1 go to 0. That's easy to understand how to draw that. Okay? Determine the Q and not Q. Output waveform of the flip-flop as shown for D and the clock input in below timing diagram. Assume that the positive X trigger flip-flop is initially reset. Okay? So they're telling you the Q zero. Okay? When the clock going 0 to 1, Q equal D, D equal 0. So they will be 0 up to here. Okay? And the next transition, Q equal to D, and D still be equal 0. So they will be 0. Next clock 0 to 1, D equal 1, Q equal 1. And they will be 1 up to next transition, D0. So they will be equal 0. Okay? And now 1. The clock going 0 to 1 here. Let's go to 1. Okay? And D equal to 1. And the transition, they still be 1. Yeah. Basically, if you understand, that's not a problem. And now for the JK. Okay? They given you the clock, the J and K, and they want to draw the output. Initially, flip-flop, reset here. They're telling you at the beginning, Q will be equal 0. So no matter what, you draw the Q. Zero. Okay? Now, when the clock going from 1 to 0, you're looking for J and K. J equal 1. K equal 1. You're looking into here. Two table. J equal 1, K equal 1. Output will be toggle. That means 0 now they toggle. They go to 1. Okay? And the next clock, you can see J0, K0. When you get the transition, they say Q no change. 1, they still be 1. And the next clock, okay, J0, K1, J0, K1. Output will be 0. Okay? And now, next clock you get 1, you get 0. Okay, J1, K0, Q equal 1. Okay? And the last one, 1, 0. They still equal 1. Okay? So basically, if you understand by looking in the truth table, that's easy for you to see how the flip-flop working. Okay, now, when you get the time, okay, you better read that. They only telling you. Flip-flop, they get preset and clear input signal. Now, why they need preset and they need clear? Okay, the thing on the flip-flop, everything, okay, in the computer, they controlled by the master clock. So that's why when you buy the computer, they're asking you what the frequency, okay? Basically, that matter frequency, they control everything. However, sometimes some flip-flop inside computer, you want the output to be a logic 1. And you don't care about the clock anymore. Then you set the active preset. Or if you want the output flip-flop to be 0 no matter what, then they're using the clear. Okay? That is very important to input. Okay? If preset equals 0, Q must be 1. Even you apply input D or clock doesn't matter, they're not working. Or if you want the clear set to 0, then Q must be 0. They ignore input either J, K, or D, okay, or the clock. So basically, they override the input and the clock. So for the normally clock JK flip-flop or D flip-flop working, that means preset and clear must set to logic 1. Okay? And both preset on and clear cannot be the same 0. Preset 0, Q must be 1. Clear 0, Q must be 0. If you set both preset and clear equal 0, so flip-flop don't know what to do. Okay? If preset 0, clear must be 1. If clear 0, preset must be 1. And again, for normal operation, preset and clear must be high. Okay? So that's telling you for two synchronous input preset and clear. Okay, I quickly go through that one for you. Okay. This is D flip-flop, clock going 0 to 1. Now, first thing you can see Q will be initially low. Okay, you get a preset. You see that? 0. Clear. 1. So you know output Q. Okay. Q will be 1. The thing is preset 0. Okay. Now you go to the next one here. You get a 1. Okay. And D, you get a 0. So when you get a clock, Q will be equal D. That means 0. And 0 go to the next. Okay. The next clock D equal 1. So Q equal 1. Okay. And this clock Q 0. D equal Q equal 0. And this clock here Q equal 1. D equal 1, Q equal 1. They supposed to be 1 up to this point. The thing is clear now 0. No matter clock output have to be 0. Okay? So if you understand that you can draw the timing, no problem. Okay? If you're looking on that one here, okay, you can see the clock will be negative going 1, 2, 3. Okay. So now we need to look into preset and clear. Okay. The thing is that override everything. So at the beginning, clear 0, preset is 1. Okay. So no matter what, output have to be 0. Okay. So when the clock going high to low, okay, you looking on pin J, 0, K, 1. Let's see, J 0, K 1, Q will be 0. Okay, and the next clock, J equal 1, K equal 1. 1 and 1. Output toggle. 0, now they go to 1. And the next clock, you can see J1, K0, Q equal 1. Okay, and the next clock, okay, 1 and 1. So they supposed to be 1 up to here. The thing is the clear now 0. So Q have to be 0. Okay. And they have to be 0. Okay. And now get the clock 1 here, 0 here. J1, K0, Q equal 1. Here, 1. Okay. And the next clock up to here. Okay. So you get 1, 1, 1, 1 toggle. They toggle to 0. And you go to next here, 0, 1, 0, 1, Q equal 0. And when you hit into here, preset 0. No matter what, Q must be 1. Okay? And when you hit into the clock here, 0, 1, 0, 1, that means 0. Go to the next clock. Okay. J0, J Let's see. Sorry.
Hey, Mr. Fan,
J zero. K zero. 0, 0. No change.
Mr. Fan,
Yeah.
if you go back to where pre was zero, was low, the dashed line that goes down shows that yeah, it's zero. The output should be pre is zero, output should be one, but it should be up to the dashed line because the dashed line is after the, the pulse.
You're talking about this part right here?
Yeah, right there, right there. The dashed line is after that pulse.
Okay.
So it goes, it goes, let me see, it's pre is zero, Q is one. It's one all the way up to that dashed line.
Okay. Right here, they will be up to this point, right? When you get a clock in here, 1 and 1, right?
Okay.
They
But
toggle.
yeah, but I'm talking about that first that
That means they
right above there. So you got pre is zero, and
they
the output is
toggle
going to
here.
be an output. No.
Okay, is it up until this point, it's right or wrong?
Um,
Okay, you can say before this clock, and you get one here, okay? And you get one here. You get a clock. They toggle. They would one now, they go 0. And
okay,
they will
no
be
problem.
go 0 up to this clock, okay? And that this clock, you get J0, K1. Output will be 0.
Right, yeah, that's right.
Will be going down, right?
Right, that's right. Go ahead. But then when the fourth arrow before the end, the fourth arrow, the dashes are before pre. Um,
Okay, they 0. Supposed to be 0 up to this clock. You see that?
I see what you're trying to do, but pre is zero, the output is one, all the way up to the transition.
You mean on the way up here? You already get a preset equal 0.
Right,
So Q have to be 1 also.
right.
So they will be 1 up here. Okay?
All right.
And when they get the clock, you see J0, K1, Q will be 0. Up to this clock, okay, you get 0, 0. No change. And up to before this clock, you get 0, 1, 0. Okay, that's it. So basically, that will be telling you everything on the D flip-flop and the JK flip-flop. You have to really understand. And another thing, you need to look back it for the D, but not clock signal. The latch. Okay, you get input D, you get the input gate. Okay, very simple. Q equal D if the gate equal 1, not transition. If the gate equal 0, then Q cannot be equal to D. Okay, and any flip-flop will be controlled also by preset and clear. Okay, that they're talking about latching. Same thing here. Input D enable. D enable equal 0. Q cannot equal D. Enable equal 1. Q will be equal D. That really you have to know. Okay? So, anyway, I still, get a problem. We get the recording for the meeting. And now, how can I let you guys see? The you. That's what I'm working on. Hopefully, next week, I have to fix on motor computer in the room 250. Make sure they will be good working for your D-Lab. Okay? Take too many years. And now we have to make sure all of those computers must be working okay. Okay, any question, anything? Okay, if it's not, okay, have a good weekend for all of you. Okay, bye bye.
Thank you.
Thank you, Mr. Graham. Bye-bye.
Bye bye.
Bye.